All right, so doing math with scientific notation. Let's say I have a mass that is 3 times 10 to the third, and then another mass 2 that is 4 times 10 to the second, and they are a distance 4 times 10 to the third meters apart. I should have said these are in kilograms, these are in kilograms. Okay, and I want to start plugging this into the relationship we had here, because this is going to be equal to g, that gravitational constant thing, m1, m2 over d squared. Okay, so how do we do this? I'm going to plug in these numbers first, and I just want to show you basically how to handle the fact that scientific notation is in these numbers. Yes, you can write all these out. Yes, you can do that in a calculator. But I would caution you that you're more likely to make a mistake in a calculator, and I think it's actually easier to keep it in scientific notation. Okay, so let's set this up. We have 3 times 10 to the third kilograms. And actually, I'm going to do this in a different color. 3 times 10 to the third. And then we have 4, the other mass, times 10 to the second. That's my other mass, all divided by distance, which is 4 times 10 to the, I need a snipping tool right now, 10 to the third, and don't forget to square it. In fact, you know what? I'm going to forget the squared, because I always forget to square it if I only see it once. I'm just going to write it twice, because I'm more likely to remember to do it if I just see it twice. So it works for me. Decide what works for you. Okay, so this is the whole right half of that equation we just set up. How are we going to do this? I used different colors here because I want to separate these. Basically, I want to look at just the numbers out front and handle the math for that, and then look at just the exponents on the right. So I'm going to separate this into, move this a little bit, all numbers out front. So 3 times 4 over 4 times 4. Now, all of this is multiplication, right? A times B is the same as B times A, so I can move stuff around. Totally cool. And I'm going to look at this side to say, okay, I have 10 to the third times 10 to the second over 10 to the third times 10 to the third. Ready? Now, the math out front is easy. 3 times 4 is 12. 4 times 4 is 16. That comes out to, scoop this up, 3/4, 0.75. Now I'm going to look at the exponents. Anytime I'm going to multiply exponents, you're going to add them up. Because really, these are just strings of tens, right? 10 times 10 times 10 times 10 times 10. That makes basically 5 tens in a row. All right, same thing down here. 10 to the third times 10 to the third would be 10 to the 3 plus 3, or 10 to the sixth. And now anytime you're going to subtract, you're going to divide. So you're going to multiply, add them up. If you're going to divide, you subtract. And if you're a kinesthetic type learner, that helps me. Don't judge. All right, so we're going to subtract. So times 10 to the 5 minus 6 is actually -1. So 10 to the -1. So be it. Now this comes out to 0, pen back, 0.75. I want to do that. Oh, no. Stay color coordinated, Jasinski. If you start with something, stick it out. 0.75 times 10 to the -1. And if you want to get that out of scientific notation, well, I should say, if you want proper scientific notation, I should get one digit out in front here. So that's 7.5. And I had to borrow a 10 to do that. So I'm going times 10 to the -2nd. Or look, this is a small enough number anyway. You could just say, hey, this is really 0.075. Cool. And that's how we're doing that. So remember, when I like to plug everything in. I like to write out the distance twice, so I don't forget to square it. Separate the numbers out front. Back to writing. Separate the numbers out front from the exponents themselves. If you're going to multiply exponents, add up the exponents. If you're going to subtract the exponents, divide those